Hey folks, welcome to this episode on empirical formulas of hydrates. Now, we don't have a question per se. We have a situation. We're doing an experiment where we have a hydrate into a test tube and we've been asked to heat it. Now, we've been warned that if we heat it too much, this hydrate will start to decompose. And so we are very, very cognizant that we are not going to heat it until it starts changing color. Now, some hydrates do change color. For example, copper 2 sulfate will go from blue to white. But this substance started off as a white solid. So if we start seeing a little bit of brown develop, we know that we are burning this and it potentially will decompose, skewing all of our results. So we're going to be paying very, very close attention to this to make sure that we are evenly heating this and we're only boiling off the water because we want to find the formula and the name of this hydrate that we're dealing with. So we know that from the beaker that we took the sample from, that this is sodium sulfate, okay? And it's some kind of hydrate of sodium sulfate. Now we masked the sample before we put it into the test tube. We also weighed the test tube so that we can do our calculations a little bit later on, but we masked our original sample. So our original sample is going to be this sodium sulfate something hydrate. We masked this to be 0.386 grams. So remember our sodium sulfate, to get this formula, sodium has a charge of 1 plus, sulfate has a charge of 2 minus, cross, and we will get Na2SO4. Now this is a hydrate. We don't know the identity of this hydrate, so I'm just going to put this variable X in front of this because we don't know what this water is yet. Now we start heating this sample in our test tube, and we start seeing a little bit of condensation happening all over the test tube. This is the water that's actually being driven off of this hydrate, and it's allowing to escape into the atmosphere. Now, some of it may condense, so you might have the angle of the test tube a little bit different, and it might collect it into a beaker or something else that you can weigh it. But then in this particular case, they're allowing it to escape into the atmosphere and get all this water of hydration out of here. And so after this happens and there's no more water that's escaping, all the condensation around the test tube is gone, they're going to take this and they're going to mask the entire test tube with the sample and then subtract the mass of the test tube, which they masked at the beginning, just to get the mass of the anhydrous salt that's going to be left over. So if they boil off all of the water, what they're going to be left with is this anhydrous salt, Na2SO4. Or I should just create a different color here for Na2SO4. And so the way they did this is, again, they originally masked the test tube. After they were done heating it and the test tube cooled down, they masked it on a scale, subtracted that mass from the test tube, and they got a number of 0.170 grams. So this is the mass of the anhydrous salt. Anhydrous meaning that it did contain water, that water was boiled off, and now it's just the salt. It's the sodium sulfate. So in order to do our our empirical formula for this, we have to figure out the mass of each component. Now this is very simple because we know that the law of conservation of mass states that matter cannot be created or destroyed, it is only conserved. So if our total sample weighed 0.386 grams, and we know that we have a mass of Na2SO4, that means that the mass of H2O that was driven off is very simple to calculate. We can just take these and subtract the two, and we will get that mass. And so if we do that, we will get 0.216 grams of water that was driven off. So now we know the mass of the Na2SO4, and we know the mass of this water, which now we can use to calculate our empirical formula. So the way that we do that, again, we're looking for the coefficients of our hydrate. So we're looking for the coefficient in front of this, and we're looking for the coefficient in front of this, not the subscripts like we would in a regular compound. So if you want to go through a little bit more explanation, please watch my previous video on empirical formulas of hydrates. But let's go into how we can calculate this. So the first thing that we want to do is we want to split up the components, Na2SO4 and water. And we know that we have 0.170 grams of this and 0.216 grams of this. Okay, we found that out through our experimental values. The first thing we want to do is we want to convert this into moles. So we need our molar masses of each of these components. So the molar mass of sodium sulfate and the molar mass of water. And if we calculate this through, this is 142.04 grams per mole, and this is going to be 18.02 grams per mole. This will allow our grams to cancel out, and we'll be left with moles. And the answer to this is going to be 0.001196846 mole of the sodium sulfate. And here we have 0.011986681 mole of the water. All right. Now, as with all empirical formula questions, we have to find our smallest mole value and divide all the mole values by that value. And so the first one, the sodium sulfate, is going to be the smallest one. So we're going to divide this by 0.011966846 mole. And we're going to do the same thing over here. I'm just going to put quotation marks so I don't have to rewrite the number. This will allow us to cancel out our moles and be left with a unitless number. Now, we know that this number divided by itself is going to equal 1. And here we get a value of 10.01522. Now, again, if you watch the previous videos, you know that this falls into the range of being able to round down. And so we will round this to 10. And perfect, we just found the coefficients of our different components. So that 1 is associated with the sodium sulfate and the 10 is associated with the water. And we just found our empirical formula. So our empirical formula is going to be 1 Na2SO4 and 10 H2O. Now we know we never write that 1 in front of as a coefficient, so this is just going to be simplified to Na2SO4 dot 10 H2O. And that is our empirical formula of this particular hydrate. Now, if we wanted to name this, we know that this is going to be sodium sulfate. You might spell it a little bit differently. It's all good. And then 10 is represented by the word deca, and we have hydrate. And there we go. That's it. Thanks very much for watching. I hope you found this helpful. Please watch the other videos with regards to molecular formula, empirical formula, both of hydrates and regular compounds. If you haven't done so already, please like and subscribe to this video and to the channel. It really does help me out. And thanks very much for watching. Catch you on the next one.